Good evening and welcome to the Institution of Mechanical Engineers Railway Division South Eastern Centre Annual General Meeting and Platform Train Interface Presentation. My name is Toby Johnson and I am the Chair of the South Eastern Centre and tonight's event. It is great to be running events again for the Railway Division after a short pause, and I hope that all our members are well. Tonight we are hosting our first event of the 2020-2021 programme and also our first webinar. Thank you for joining us tonight, and I hope that you enjoyed tonight's talk from Neil Goffton. The agenda this evening will be a short annual general meeting for the Railway Division South Eastern Centre, chaired by myself, followed by a presentation on the RSSB's latest research into high and wide platforms. There will be a chance for questions and answers at the end of Neil's presentation. To post a question, please use the Ask a Question tab on the right of your screen. So, without further ado, let's make a start with tonight's AGM presentation before I hand over to Neil to speak. So, the AGM will cover last year's performance, both in terms of attendance of events and finance, plus a look ahead at this year. I will take you through the committee for this year and also our planned events. So looking back last year, we managed to run 6 of our 7 planned events, and throughout the year we had a very healthy and regular attendance at all of these events. I hope you enjoyed them. So in terms of the committee for next year, again, it will be myself as chair. We have a vacancy for vice chair, as our previous vice chair, Nigel Cartledge, has now stepped down from the committee. Kevin Moore again will be doing the secretary role. We have a new treasurer in IMechE, a new young members representative, Chen Ti-Ying, and we have Fazal Ahmed as communications officer, and also Tim Poole on our committee. So this is a quick look at last year's and this year's finances. The IMechE financial years run in calendar years rather than the more usual financial year. Hence we present 2 years worth of reports. Unfortunately, we're no longer able to use 55 Broadway for our face-to-face events, which was free of charge. So we're looking at other free of charge venues in Westminster and Southwark to continue saving this expense. We hope to be able to restart our face-to-face events once lockdown measures are eased. I don't want to spend too long on the Treasurer's report, the finances, but just to point out that our 2020 account balance and year-to-date spending is quite significantly underspent. This is obviously due to the fact that we can't run any face-to-face events, and we're no longer being able to provide event catering. So we will end the year with quite a healthy surplus. We hope to be able to therefore not apply for a grant from the IMechE headquarters for next year's events. So also looking forward, this is our intended programme for 2020-2021. Today we've got Platform Train Interface Presentation. In September we'll be having a talk from the Railway Division Chair, Felix Schmidt, on the long history and exciting future of railway systems thinking. Bookings are available for that webinar now on the website, the EU website. We've also got a presentation on the evolution of Hitachi trains in October. And then we've got a joint event in November with the North Eastern Centre on the judicious mix for rail decarbonisation. Into 2021, we're having a presentation jointly from Siemens and Transport for London on the new deep tube trains. And of course, we will be having the South Eastern Centre heat for the Future of Rail presentation competition. In March, we've got Network Rail talking on-track machines for infrastructure maintenance, and we'll be closing out the year with the introduction of the Crossrail fleet from one of the engineers on the front line. I'll put a hyperlink to our website on the IMechE Near You pages. Please keep an eye on this because we will be updating that regularly with all the information on our events. We are intending to run all of the events in 2020 as webinars, so please do sign up for those. Hopefully in 2021 we'll be able to resume face-to-face meetings. So that's it really for the AGM. I wanted to keep it short and sweet so that we could move on to tonight's main event, which of course is Platform Train Interface. I'd like to introduce tonight's speaker, Neil Goffton. Neil is Principal Track Engineer at Rail Safety and Standards Board, where he is a technical specialist supporting development of infrastructure standards and contributing to infrastructure-related research projects. He is a chartered mechanical engineer with 15 years experience in the rail industry and is a member of the IMechE and Permanent Way Institution. Neil is currently the convener of the CEN working group developing European standards for railway switches and crossings. Previously, Neil worked for Transport for London as Principal Track Engineer, working to enhance the maturity of predictive maintenance for switches and crossings. Previously, within TfL, Neil worked for the track engineering team, providing technical support to track maintenance areas, challenging and improving standards and processes. In Neil's early career, he worked in frontline track maintenance on both London Underground and Network Rail infrastructure in supervisory and technical roles. Neil, over to you.
Thank you, Toby. Thank you for that introduction, and thank you to everybody for having me to, at least virtually, to talk to you about platform train interface and specifically high and tight platforms. In terms of today's lecture, what I'm going to try and cover is a recap on why the platform train interface is so important and what sort of things are being done to improve the current platform train interface. How do we define nominal platform positions in GB, and what sort of platforms do we actually have in reality? What do we mean by high and tight platforms, and what are the implications for these for the design of rolling stock and the implementation of footstep position for the platform train interface? And I'm going to give you a bit of a flavour about T1166, a recently concluded project which was looking at potential opportunities to remove some of the high and tight platforms and how we might go about making a case for that. I will start with a bit of an apology to any London Underground people listening today, because most of the numbers I provided within this presentation are mainline related. However, hopefully there's still some relevant learning and principles that can be applied across the piece. So why is it so important? Well, in terms of PTI risk, it's still one of the biggest risks to passengers on our railway. If we look at the recent health and safety data specific to station operations for last year, you can see that risk around the PTI equates to around 14 fatalities and weighted physical injuries per year. And perhaps most importantly, what we can see is that there isn't really a downward trend that we would like to see. It's perhaps not increasing so much, but it's certainly not coming down. So it's still a very relevant risk and something that we need to be continued to provide solutions and mitigation measures. If we look to the graphs along the bottom here, you can see fatalities on the left, major injuries in the centre, and minor injuries on the right. Now, what we know from incident data is fatalities tend to not be associated with the specifics of boarding and alighting, whilst injuries, there's a far higher risk during boarding and alighting. So in terms of stepping and passengers boarding and alighting the train, we do injure people, and that risk still is very, very relevant. So we need to continue to provide solutions. Back in 2015, the industry first published its platform train interface strategy. This was developed by a cross-industry group led by Network Rail and had heavy involvement from the train operators. And what this was really trying to do was bring together all the issues associated with platform train interface and identify areas where industry needed to focus efforts to seek out improvements. And as well as safety, it's also looking at performance and capacity, passenger train movement through the station, as we know that incidents that occur at the interface aren't necessarily just solely down to the interface. It can be influenced by what a passenger might see as they make their way through the station. Train stopping positions and dispatch procedures, and then optimization of the step gap dimensions and improving accessibility. And what we do recognise is that certainly for the GB mainline network is that we have many challenges that occur from mixed traffic railway with legacy trains and legacy infrastructure. And I'll bring out some of those issues as we go through tonight's talk. So we think back to those incidents in the PCI risk data and the safety report that I mentioned a couple of slides back. And we can think about incidents in three sort of specific areas of the platform. The first one there, incidents associated with the interface itself, with the train in the platform. So perhaps issues with people getting trapped indoors, contact with train, the exterior of a train or moving train while standing on the platform, persons falling between the platform and the train, but not at the door positions, and slips, trips and falls across the platform interface. The second area is encapsulates falls from the platform onto the track, where there isn't a train in the platform, which is still relevant captured as part of these incidents. The third area, and something that the last few years become even more relevant with incidents occurring, is wheeled transport rolling off platforms. And unfortunately, in the industry, we have a legacy of many platforms with a adverse crossfall towards the track as opposed to away from the track, which with increased with aerodynamic effects from passing trains, etc., it can be very easy for these devices, wheelchairs, pushchairs, and other wheeled transport to towards the track and fall onto the track. So these are the sorts of incidents that feature within the incident data. So picking up on a few research projects that have taken place since the platform train interface strategy was published, or I say the first one was around the time of the publication of the strategy. The first two, T866 and T1037, looking respectively at the actual platform edge positions that we have on the GB network and understanding the actual footstep positions that we have with vehicles operating on the network, and to understand the actual gauging constraints and compatibility between those two aspects of the system. And I'll go into a lot of that more about that data as we progress through the slides, but very important from the strategy point of view to understand what we actually have within the industry operating on the network. T1054, that was a project that was evaluating gap fillers and looking to reduce the risk of the platform train interface, particularly in boarding and alighting. And T1062 which was a project looking at the ongoing need for platform recess requirements. So when I refer to platform recess, I'm talking about the space underneath the edge of the platform where there's roll-away space for somebody that might find themselves falling from a platform to the track, or indeed, as evidence was found within the project, for emergency services to get to someone that may have fallen onto the track whilst the train's in the platform. T1098 was a project looking at mitigations for the risk of unplanned movement of wheelchairs and pushchairs on station platforms. And those three projects that I just mentioned there have now concluded, and results have actually been migrated into standards. So new requirements and guidance is out there now for the industry to use. T1102 was a project looking at optimizing door closure arrangements to improve boarding and alighting. And T1118 was a project looking at yellow lines and platform markings. And anyone out and about on our network will have seen, as an industry, we're probably not as consistent as we should be with yellow lines and platform markings. So the outputs of that project will help us be more consistent. And then I'm going to go on in the bulk of the later part of today's talk to talk about T1166, which was looking specifically at high and tight platforms and what we can do about those to help reduce platform stepping across certain routes. So what is good platform train interface? Well, some people may have seen operators measure platform stepping arrangements using a gauge not dissimilar to the one here in the diagram, in the photograph. But that's measuring actual platform stepping dimensions to actual trains with it stops within a platform. But what about standards? Well, in terms of standards, we specify a vehicle footstep position relative to a nominal platform, not actual platforms. So what we say is that if you're someone designing or building a new train, would have to see that their footstep complies with that red box stepping window to a nominal platform position, not an actual. If we look at what we say, what European legislation says in terms of specifications of interoperability, that would define unassisted boarding if the horizontal gap is less than 75 millimeters and a vertical step of less than 50 millimeters up or down. But is this the negotiation by a wheelchair, and at the same time, in achieving a better vertical access, do you also introduce a potential trip hazard for other passengers at the same time? So it's a balancing act. Just to recap on definitions and datum positions that I'll talk about in tonight's lecture. When we're talking about platform height, we're talking about a vertical measurement from the plane of the running rails to the surface of the platform. And offset is the measurement from the running face to the platform, its edge itself. However, this is slightly more complicated in curved and canted track situations. And this is illustrated in the figure on the right hand side. In terms of the footstep, we talk about a vertical step and a horizontal gap. So I will use those terms tonight. So when I'm talking about vertical, I'm talking about the step, and horizontal, the horizontal gap. So what are the current requirements for platforms? The infrastructure TSI sets out platform heights at 550 millimeters or 760 as measured from the plane of the running rails. And the offset's governed by the European suite of gauging standards, which isn't terribly relevant for most GB platforms. So what do we have? Well, for GB, we have specific cases for both platform height and platform offset. And the specific cases refer to national technical rules. For platform height, is governed by Railway Group Standard, GIRT 7020, and that establishes a nominal platform height of 915 millimeters. And the offset is governed by the gauging standards, and it's generally the nominal position is 730, although this is increased in certain circumstances for horizontal curvature. What about tolerance? We have a nominal height dimension, and historically we had a one-way tolerance for platform height. Tolerances were 915 plus 0 millimeters at minus 25 millimeters, giving a range of anywhere for a compliant platform from 890 to 915. However, it's not terribly easy building to a one-way tolerance, and this gives projects problems in actually building to these. And what the result is, resulting actually leading to lower platforms with a constructor tolerance effectively designed in to enable to achieve a compliant 915 height. But to increase this, potentially introduce gauging problems for rolling stock. However, many of our platforms are not currently at the correct window for platform height. So following wide industry consultation, it was agreed that the tolerances would be modified in the publication of GIRT 7020 in 2018, and the gauging tolerances were updated accordingly. So to summarise what changed, you can see on the right-hand side of this slide, the previous situation, the green box for design tolerance for platforms, was 915 upper limit down to 890. With the change in the publication of GIRT 7020 in 2018, what you have is a smaller box for design, but we've allowed an extra 10 mm build tolerance above the 915. And the idea of this build tolerance was to enable designers to put the design position of the platform close to where we want it to be in terms of height at 915, whilst allowing for a bit of wiggle room on site to ensure compliant build. The small purple box at the bottom is to enable for certain legacy rolling stock. So whilst we've effectively moved that window of tolerance up vertically, there are certain rolling stock still in operation that potentially lead to conflict from a gauging perspective. So that purple box has enabled those platforms to still go down to 890 in certain circumstances where those vehicles operate. And to overcome the potential conflicts with gauging, the thresholds for the relative gauging bands were reduced accordingly. What about the requirements for footstep? As I said before, the requirements for the position of a footstep are relative to a standard platform, not actual platform positions along a route. From the PRM TSI allows for a step down into a train as well as a step up into a train. However, it doesn't allow for oversail, which for certain fleets on our network is what we currently have. The GB specific case formally did allow for oversail condition, but did not allow for a step down into the train. The problem we had is not too long ago, there was actually an opportunity for people to use either or stepping box and achieve full compliance. What we have done recently is to bring these two windows together into the current issue of GIRT 2173 to ensure consistency of application between the two standards. So we now will allow for a space that caters for both the step up condition and step down condition and the oversail condition. But quite often the question is asked about alternative platform heights. And going back to the beginnings of the PTI strategy, a lot of work was done to reconsider whether 915 platform height is the right height for our platforms across the GB. So what you see here on this plot is each of those blue blobs represents the end of a footstep position of existing rolling stock operating on the network. And at the bottom right hand corner you see the target platform position. So if you consider this as a cross section zoomed in on the interface, with the center line of the track somewhere off to the left and the rails somewhere down diagonally to the bottom left. Various platforms over the years have been proposed as sensible alternatives, some of which I've highlighted here on the slide and were reviewed as part of the development of the platform train interface strategy. Of course, as you increase the height, you are able to reduce vertical footstep, which obviously is a good thing in its own right. However, there's a conflict with clearance, and in order to achieve the necessary clearance against these trains, the resultant position would be to increase the lateral position, which in turn, whilst achieving a far reduced vertical footstep, could induce quite a significant increase in horizontal offset. And if you take the first case on there, first alternative case of a platform height of 945, the offset would increase up to 850 in order to achieve gauge compatibility with existing footsteps. So quite a significant increase in offset for a relatively small benefit in height. So at the time, the PTI strategy concluded that 915 remains the appropriate target platform height, and that we need to find a way as an industry to continue to move towards getting more and more platforms towards this target platform height. What about different types of vehicles and different age of vehicles? Well, this is the same plot again, same footstep positions, but this time color-coded by the age of the vehicle. And whilst the older vehicles are generally more scattered, probably because they're tuned more specifically to the routes in which they ran, the more recent vehicles have perhaps a more consistent position for footstep, but at the same time are generally higher, induce a quite high and wide footstep position. So perhaps go anywhere trains aren't helping in terms of PTI strategy. But what do we have in the real world? So thinking specifically about platforms, in the ideal world, all platforms would be nice and straight. All platforms would be in their standard position from an offset and a vertical height. We'd have a track form that was high in track fixity that didn't move throughout its life and would enable confidence in consistent track position. We'd have all trains the same, door positions the same, so we know exactly where people are boarding and alighting. Consistent stopping pattern. So in the real world, some platforms are straight, and actually quite a significant proportion of our platforms are curves. And they're platforms areas that wouldn't enable for easy alteration or straightening. So we generally will have to live with platform curvatures. The platform curvatures is straight away you introduce some conflict from a platform train interface point of view. To achieve clearance at the ends and in the center, you potentially compromise the stepping positions at the door positions shown here in the diagram on the right. And if you look at the data on the graph there, you can see that actually 22% of our platforms have a curvature of 1,000 meters or less, so almost a quarter. And of course, track curvature and platform train interface is complicated further, where curvature introduces cant into the track. So, ideal world 1, real world 0. And what about standard platform position? What do we have in the real world? We've talked already about what the nominal position is and where we want platforms to be, but most platforms aren't at this position. Standards aren't retrospective, so there's no requirement to go back and modify them. And to be honest, there is no budget or funding for works to go and rectify or modify some of these platforms. And probably for a large proportion of station works, the platform itself is not necessarily in scope. If we look closely at the data for height, you can see that 30% of our platforms, just 30% of our platforms are in what we would define as the right position for platform height, and only 22% are in the right position for platform offset. And perhaps even more concerning is that when you look at both offset and height, only 7% of platforms across the network are in the correct range for both. So again, real world comes up short. What about track? Well, the majority of mainline track is ballasted, and the majority of platforms in GB mainline are ballasted as well. So depending on the construction of the platform wall and what's around the track itself, there is a degree of movement to be managed. Are all the trains the same? Well, we have a wide variety of trains operating on the network with different speeds, different steps, fixed and deployable, lengths of individual carriages, different configurations of train and consist, all introducing different points of standing on the platform. So again, challenges in the real world that we have to manage. And what about door positions? Ideally, door positions would all be the same, but in the real world, we have different train designs. As with the different lengths, we have different designs with vehicles with doors at the ends of carriages, doors at 1/3 and 2/3 positions, and vehicles with doors in the centre, all of which are challenges to overcome in terms of the interface. Given the type of operation we have across the mainline network, there's many different stopping patterns, again, not consistent. And of course, for many platforms, we have to manage freight as well. Freight, and particularly container units, introducing a trade-off between gauge clearance and stepping distance. But not just that, thinking back to our areas on the platform where risk of incidents comes in, we also need to think about aerodynamic effects and undesirable aerodynamic effects from freight trains as well. So quite a number of things to have to manage from train interface right. So is it all hopeless? Is there too much to overcome? Well, no, industry is doing things, and things are improving, but we can do an awful lot more and need to do more. Let's stop for a moment and think about horizontal gaps. And going back a few years with Heathrow Express, there were normally it's a level access railway with unassisted boarding and pretty small gaps to manage. But there was still a significant number of PTI incidents. One solution that was introduced was to deploy a gap filler along the platform. And this helped to avoid a number of incidents and showed that actually, even with the small gaps that were previously present, there are still issues for some passengers to traverse the gap. So again, what is good PTI? Well, wheelchair access users need level access for unassisted boarding, but what is level, and how do we keep it level? In terms of small steps, HS2 studies have identified that more than one small step can be a serious obstacle, and in fact, indeed a tripping hazard. And what is the optimum for different passenger groups? Some studies have indicated that adults may see different footstep configurations as challenges to children, or to elderly, or to mobility impaired users. And what about people with buggies or luggage and things like that? And it comes back to this balance. How do we balance a horizontal gap with a vertical step? A small step could be a trip hazard for some, a large step an obstacle. Whilst a moderate step may be normal, a gap is perhaps more disturbing, particularly when you consider that when boarding or alighting a train, you're stepping over what is dimensionally a relatively small gap, but that's stepping over a 3 or 4 foot drop. So the task of the engineer is to find solutions that can work in the real world, not to think about the ideal world and wish that's what we had. So let's think more specifically about the challenge that we've got. So as I said, the PTI strategy work has indicated that 915 remains the target platform height of the GB mixed traffic railway with the current vehicles that are in operation. But how do we go about funding a project or projects to go through and modify a series of platforms to improve the situation? What you can see there on the slide is a distribution of offset and height. So offset going left to right along the page, and height distribution going into the page with a number of platforms on the vertical axis. You can see the arrow there with the smiley face to the purple bit in the middle. That is the proportion of the platforms that are in the right place, both horizontally and vertically. So you can see the volume of both the volume of platforms we would need to correct to bring to that central spot, and you can see the scale of the task. But what are we trying to do? Well, ultimately, we want to get those blue spots, which represent the footstep positions, closer, as can be achieved with gauge compatibility, to improve the stepping. And that's where the high and tight projects come into play. Because actually, when you look at the graph on the right-hand side there, there's actually a relatively small number of platforms, when you consider the bigger picture, that are influencing the footstep position of the Go Anywhere trains and pushing them to the extremes of the stepping window. So the scope of T1166 is to determine the critical locations, understand those sites and the constraints, and see what could be done to modify those platform sites, and look at the business case for doing so. I'm going to touch on some of the analysis in making that case in a short while. And the idea of the project being that if we can do something with those few platforms, that will potentially enable us to achieve a benefit across much larger parts of routes. If I try and present that in a slightly different way, and I apologise, I've done this for this talk and I'm not sure it entirely works, so I'll try and explain it. Each one of these blobs on this graph is a measured platform position across the network. So thousands and thousands and thousands of measurement points here. I will say, and I'll caveat this with that, I'm sure there are some errors in these, particularly with the ones off to the left of the chart. This is a fairly raw data set that I haven't cleansed. So the blobs represent a platform measurements. So that's actually the distribution of what we have out on the network. And to put that in context, the small yellow box in the center of the slide is the actual window of compliance. So if we were building a new platform today, that is where the platform would need to be. So the legacy of what we've got is distributed broader than where we need to be. And if we think about the footstep positions, so the same footsteps that we saw on the earlier slides here are represented by each of these orange lines on the slide. And those are really influenced by the grey positions that we can see here in the top left of the distribution. So if we can do something with those relatively small platforms, relatively small number of platforms, we can actually provide the opportunity to realize a much better interface across the majority of the others. But how do we make the case? One of the challenges we have is that although we recognize that there is safety risk associated with the interface, and that we do know that a number of these things, incidents, are associated with boarding and alighting. One of the things it's very difficult to do from the safety data that's currently available is to pinpoint incidents back to defined stepping dimensions. Safety incidents can be attributed to platforms, but perhaps more often than not just stations. So, and almost certainly not the position along the platform and what the interface actually was, and the train that happened to be that it happened to occur with. So incredibly difficult to try and pin back safety, the safety argument. Coming back to so coming at it from another angle, the project looked at to see if it could correlate performance data to see if there was a correlation between platform and offset and delay to service. And it looked at some data on cross-country routes, which was quite robust and quite helpful because over the window of time considered, service patterns were fairly consistent and the use of rolling stock type was fairly consistent, which made it easier to align actual stepping dimensions. In terms of data sources, we looked at gauging data in terms of those data sets I talked about earlier from T866 and T1037 for platform position and footstep positions. It looked at incident data for performance. It factored in timetable planning rules, particularly dwell times. It looked at station usage data, high volume usage. Obviously, you'd expect a higher propensity for delay, but also the types of users that might be operating through, might be using the station. It also looked at whether platforms were manned or unmanned, and the allocations, of course, of different train types to different platforms. So the project was able to identify a relationship between platform height and the ratio of primary delay to station dwell, for instance. So that's a good outcome. We've been able to demonstrate through data that there is a correlation between height and performance. Unfortunately, it wasn't possible through the project to identify the same relationship between platform offset and delay, which perhaps a bit of a head scratcher, but it doesn't necessarily mean that there isn't a relationship, just that it hasn't been able to be shown. And in a similar way to the safety data, other factors come into play. For platform offset, track curvature has an influence. Dispatch procedures may be different for track curvature. It's also much harder to attribute a stepping dimension horizontally when this can vary along the length of a curved platform that's for gauge clearance. So it's difficult to try and identify that correlation through the noise of the other factors that come into play with platform offset. So having found that correlation, the project went on to test 3 cases on 4 routes it looked at. The first test was, well, what would happen if you could lower all the platforms that were over 915 down to the compliant 915 hive dimension. The second test looked at what would happen if you just took 50% of the high platforms and brought them down to the 915. And the third test looked at, well, what if you only dealt with the notable outliers, those with a standard deviation higher than the average of all the platforms above 915. And the 2 tables here kind of give a feel for what that would look like. So on the left-hand side, test this the number of platforms that would require some modification work in order to achieve the test. And on the right-hand side, these are the dimensions that ultimately you'd be left with driving the footstep position after you've done those works. So having looked at that, going to the correlation that was determined in the data around delay minutes attributed to height and offset, the project then identified how many delay minutes potentially you could save in each one of those cases. And of course, once you get to delay minutes, it's far easier to attribute a monetary value to the benefit. What the project, for other parts of the project, we're looking at modification, mitigation measures, and so as part of the business case, the project considered a generic cost for infrastructure modification for each platform, i.e. a typical cost to achieve a track lift, and a rolling stock cost for rolling stock modification, which essentially would result in a lower step position. We looked at the idea being that if you could modify those platforms and get a lower position in that top corner, you could then modify the rolling stock to bring, which ultimately will result in a lower stepping configuration across the whole of the platforms on the route. So when it looked at the modifications, considering modifications to both the infrastructure and the rolling stock, the benefits case came out fairly low, perhaps unsurprisingly, which may be disappointing, but perhaps understandable given the delay minutes that could be saved. However, what the project went on to look at is actually the case for modifying the infrastructure at the point of new fleet introduction. And whilst it was it found that there was a BCR a benefits cost ratio of around 1.5 to 2 in the various test cases. What you could say is that whilst there's a potential quantifiable benefit here for performance in relation to the height, you would also be there are also safety benefits that couldn't be quantified in quite the same way. So there potentially is a case for doing this work at the point of fleet introduction. Of course, in new vehicles, you wouldn't need to make the modifications to the footstep. The footstep position and configuration could be designed in accordance with the development and deployment of the fleet. Thinking more generally about recent projects and solutions that have been implemented for the platform train interface. If we think about Link Central Core, it deployed raised sections of platforms to vastly improve the interface around accessible doors. We have single train type here, so there's a relatively opportunity for consistent step position across the section. Consistent door positions. Gap fillers also used on the raised section to help mitigate that small gap that we talked about earlier, horizontal gap. And of course, fortunately, there's no freight traffic to bring challenges for gauge clearance and aerodynamic effects. What about other projects? Well, lower floors. We've seen lower floors introduced on the underground with SDOC. Greater Anglia is seeing trains being introduced with lower floor heights, and additionally deployable bridging plates from the train, which help to reduce further that horizontal gap. So whilst the train floor is achieving a improved vertical step arrangement, the deployable bridging plate reducing the horizontal. Thinking Merseyrail, similar trains, but also additionally with Merseyrail, the modification to body profile there, you can just see in the picture where you actually have been able to reduce the gap between the train and the platform away from door positions to help try and mitigate some of those incidents associated with falling between train and platform away from boarding, and improve lighting condition effects around the door. And also, as was borne out in the T11 66 data, Merseyrail projects have also done a lot of work to bring platforms to the target platform position, which has helped with the deployment of the trains with the floor heights and the steps. So, kind of to conclude some of the main points from today, our platforms aren't consistent. We are left with legacy of platforms from a range of railways coming together and evolving over many decades, and we need to find a way to get to a more consistent position. We've shown with the T1166 project that the case can be made for doing that in certain situations with new fleet introduction and infrastructure modifications, thinking of it on a system-wide view, and indeed Merseyrail have demonstrated that through the work that they have done. We've talked about specific solutions at certain points along the track, that we've seen to achieve improved platform train interfaces at specific door along the train. About vehicle floor and step height, increased propensity for vehicles with a floor height more consistent with platform position. That's fantastic and is helping the problem, but surely as across the piece we need to get to a more consistent platform height for those solutions to be truly fully effective. What about go anywhere trains? Maybe more route specific footsteps are a required solution, with the ability to modify some of these if they're needed. And perhaps that's a better solution. And again, with the more use of deployable or semi-smart footsteps, can that help with the range of platforms that we have? Or again, do we need to find more consistent platform dimensions for them to be truly effective? And in terms of the platform, deployable platform sections, smart gap fillers or gap fillers, how effective do they work in the real world as solutions? So hopefully that's given to think about. I've talked about various things in brief that have been going on within RSSB there. There's a bit more detail on the project there dealing with high and tight platforms. You can find out a whole lot more about all of those projects referenced in the presentation through our website and through Spark Rail. and or contacting me and my colleagues directly, and we'll see if we can help. I can now probably take some of the questions that have come through. So if I hand back to Toby, and I'll answer the questions as they come through.
Thanks very much, Neil. Thanks for your presentation. I really enjoyed that. Quite a few questions come in, so we'll try and get through as many as we can. So there's been a couple of questions that have come in from Ian Cook. His first question: are you going to consult with disabled people or mobility impaired people before any work is carried out, as they know what they need, not what they think they need, which has been the problem in the past when building accessible building stations, etc. And the second part to his question was, when will level boarding be standard?
Okay. Well, perhaps I'll take the first question first. Short answer is, I think I don't think I mentioned it. In terms of PTI risk and the management and I suppose ownership of a number of these projects falls under the Persons on Trains and Station Safety Risk Group, and they have routes into the communities for people with persons with reduced mobility. So there is an input to what we do at RSSB and specific projects. So I've probably talked a bit more general about things today. Obviously, specific locations and specific projects will be liaised appropriately through their local communities in delivery, but certainly in terms of the general research and the national rules that we write within our standards, we have mechanisms to ensure that we are getting the views of disabled people into what's written. And as I said in the presentation, it's also about finding, we have to find a balance in certain situations where, and perhaps the humps are a good example, whereby a level access is achieved locally for accessible door positions and managed perhaps slightly differently to other boarding positions along the platform, where which may be more a conventional stepping arrangement. So when will level boarding be standard? Again, going back to my platform height slide, it's incredibly challenging, and probably I would say not until deployable footsteps are a routine solution on many rolling stock, because to get the platform height to the right place, we're almost certainly got to compromise the horizontal offset. And so again, it's coming back to that balance of getting what is the best interface, rather perhaps than achieving one of the dimensions over the other.
Okay, thank you. Right, we'll move on to a question from Malcolm Derbell. In the blob chart, which was you presented, were you really showing a situation where there are physical fouls?
So yeah, I apologise, I did, but I've trying to illustrate a point, and I haven't cleansed that data set, so I suspect there are some erroneous data points, particularly on the left of that chart. However, what that's also showing is a network viewpoint, and some of those blobs in the top left hand corner may be valid and may be real, but they might never actually see a footstep that is also on that graph, because certain vehicle types would not necessarily operate on every route with those platforms. So it's a difficult way to try and illustrate the main point that it's the ones in the top left we're interested in to achieve the better footstep. However, not every single one of those blobs on the chart will see every single one of those footsteps. And I think if I go back to the slide with the color code, I wonder if I can go back quickly. Which slide number was it? If I go back to the slide number with the coloured footstep positions, the more scattered arrangement for the earlier stock types, which is almost certainly down to footsteps probably designed for the routes on which the vehicles were operating. So, short answer, no, I'm not 200% physical fouls. I suspect somewhere there, if there are physical fouls, are erroneous data points.
Okay, yeah. There was a second part of Malcolm's question, which was, is it fair to say that the cost of fixing the offset would be marginal if carried out whilst fixing the height?
It depends. The fortunate thing about, the positive about the being able to get the direct correlation to height is that in many situations height is relatively easy to fix. If it's a sense of a track lift with a tamper, it's a relatively easy thing to get it to the track to the right height for the optimal offset. If it's a case that a track realignment can also achieve the offset benefit, then I would say yes, absolutely, it would be marginal, and I would expect that to be done anyway. If we were doing, going there to achieve a height, and it was possible to optimize the offset at the same time, we should be doing that, and the cost would be marginal. If it's a case of a tight 6-foot position, whereby there would be knock-on effects on adjacent roads and adjacent platforms, it will become slightly more complicated. So it's quite a case-specific situation. I make quite a general sweeping statement there to say that it's relatively easy to fix height. Of course, we have the added complication of overhead wires in large proportions of the network as well, that aren't always as high as perhaps the track system might like them to be, and that brings its own challenges. So, in theory, it's easy to do height. We should be looking at offset at the same time as rectifying any height. It may not be as easy.
Sorry, I think I had myself on mute there. There's a question that says, related to your last point, Neil, about overhead line, from Zoe Borum. She asked, why were cross-country routes chosen? Routes with lots of very high platforms generally have overhead line, and the high platforms are caused by lowering the track to achieve electrical clearance.
Yeah, I mean, why there was probably more to do with the data that was available, the train types operated, and the the spread of platforms covered. So that was perhaps why they were chosen. I completely agree with the point around the track lowering to achieve electrical clearance, and it is a real problem. And one of the things that we've seen come through to RSSB and through deviations to Infrastructure Standards Committee, and it's situations where industry has been able to lock in a problem by essentially, we've seen examples where structures have been put in which have then locked the overheads in an undesirable position, which then has effectively fixed in an undesirable platform and track position to an undesirable position that's probably cost prohibitive to fix in any easy way. So organisation in terms of high platforms being an easy fix. Obviously, the overhead lines have to be considered, and they will present challenges in certain situations that perhaps can't be overcome or need a bigger investment to overcome them.
Okay, yeah, thanks for that, Neil. We had a question here from Barry Gardner around platform screen doors. So platform screen doors around the world are used for energy saving and safety, particularly at busier stations. What is the UK doing?
Again, it probably comes back to the mixed train traffic slides I showed with the different train consists and the different door positions. And I think probably at the moment it's really in the too difficult box for most of our platforms, because the variety of train door positions and the train lengths and train stopping positions that exist on many platforms potentially make it very, very difficult to try and achieve a platform edge door and barrier solution in the right place. Obviously on captive routes and networks where there's consistent fleets operating and consistent stopping patterns, it's far easier to do that. But I think probably for some of these platforms I'm referring to on the main line, it's very difficult to try and get a solution for platform screen doors.
Okay, thanks for your answer, Neil, there. We've got a question here from David Shires. Simply, is level access possible on a mixed traffic railway?
I think probably defer to my earlier response in terms of it probably is possible when at a point of deployable steps are more consistent across fleets, which is probably some years into the future, whereby think about the slide. I'll go back. The photograph at the top here with the horizontal deployable bridging plate. If you had consistent platform positions, that's some years into the future, I would say, with investment to get there.
Yeah, that's right. Okay. So we've got a question from Louise Shaw. You may have some thoughts on this. IEP train footsteps are considerably worse than the trains they replaced, too high and too far away for many people. What has caused this?
So I think this is probably one of the examples that fits into that the go anywhere sort of train influenced by those high end type platforms that are pushing that step into those away, if you like, and completely understandably. So again, I think it's if we can get rid of those ones at the top there, top left hand corner, if we can deal with those few, that would avoid that footsteps being pushed to the extreme of the window of compliance.
Okay. There's a few questions coming in sort of around the train, the rolling stock design. One here from Derek Hurst. If 915 is the optimum platform height, will there be a long-term aim to get standard train floor height at approximately the same dimension in order to obtain level boarding?
Good question. I'm not sure it's there yet. I haven't seen it. I mean, I'd probably have to defer to my rolling stock colleagues to get a flavour of that, but I don't think we're there yet. I think it perhaps be driven by demand at the moment. As I say, I cited 2 projects in this slide that have adopted a lower floor height vehicle to achieve a more consistent dimension. As I said, S-Stock's been operational on the underground for many years now with a lower floor height configuration. So I can see it becoming more and more popular. That might then drive a standard floor height, but I don't think I see that in the near future.
Yeah, one to work towards. Is there, I have one more question from Chris Jackson. So in terms of overall PTI risk, does the larger number of low platforms present a bigger safety issue than the high and wide platforms displacing footsteps to increase the step gap?
It is a problem and potentially a bigger problem. And I think, but I think what and the correlation applies across the range of platforms. So whilst T1166 was looking specifically at the high and tight and what we can do about those to bring the footsteps down, or at least prevent pushing them to the extremes of the compliant window. Ultimately, you can go back and apply the same case, generate the same case for the low ones, because that correlation is there. So the reason we focused on the high ones is because they're the ones driving the footstep position. You can't get any benefit if you can't bring that footstep down or get footsteps to a lower position. If you get the footsteps down, you can get benefit across the range, but at the same time, you can equally bring those platforms up to the right window for platform height as well, and offset. So I think across the piece, we need to improve and continue to improve the dimensions. But this was specifically looking at how we can prevent pushing that footstep higher. But absolutely right. The low and wide ones are equally as important to deal with.
Okay, thank you very much, Neil. I think you've fielded a wide range of quite challenging questions there. So thank you very much for doing that. I'd just like to close tonight's proceedings really by saying Thank you very much to Neil Goffton for giving such an interesting and enlightening talk. I think you've clearly defined and articulated the problems that we face with a lot of our legacy infrastructure. Your presentation of a data-driven approach to looking at understanding the delays that are subsequently caused with a clear demonstration that a business case can be developed for improving the current situation, most probably at the point of fleet introduction. It's clear that it's not an easy problem to solve, and it will take many years of thought and money to resolve. So, Neil, thank you very much. I'd just like to finish tonight by saying a few more things. Tonight's webinar has been recorded and it will be available on the IMechE's webinar hub. As you registered for the event, you should be sent a hyperlink to this talk very shortly. I'd also like to say thank you to Emma Pateman at the institution for her support in making this evening's webinar happen. If you have any comments or suggestions for improvement of these events, then I would like to hear from you. Feel free to get in touch with me. You can email me at which is rdsoutheastchair@imechenearyou.org or through our Near You web pages. So thank you very much all for attending. Thank you for listening. Thank you for your attention, and thank you for those that submitted your questions. I hope that you found this evening's event informative and enjoyable. Our next event is on the 14th of September, and that's Felix Schmidt's presentation, his chair's address on railway systems, and I hope that you will register and that we'll see you there. Thank you very much. Good evening.
Thank you.